Alright, group quiz. Yeah, 20% group and group adjustment copy, yada yada yada. Okay. You want to swim from one side of the river to another side. Assuming your speed is 3 miles per hour in the west direction. Velocity. When you reach a certain point, you encounter a water flow with a velocity of 6.2 miles per hour in the north direction. Both in speed and direction. Vector, so.
Yeah. Okay. So you're going
We're going
west.
due west, so I don't know, I'm assuming this is like a graph, so I guess west could be like the x coordinate. At least the left, going left on the x coordinate could be west.
Yeah.
Let's see. 6.2 miles per hour in the north direction. You're going 3 in the west direction. Okay.
So wouldn't the speed just be the two speeds combined?
That's what I'm trying to figure out. Let's see. I don't know. It's been a long day. I'm probably forgetting stuff, so I'm trying to see what I can find. Because I wonder if it is the two combined, at least combined, like squared combined, and then square root maybe. I don't know.
Yeah. Because this question is different from the one we did on Tuesday.
Yeah. Let's see. Any vector is the horizontal and vertical components. Okay. Let's see. The resultant vector, in a way,
Just 1 minute.
stands for this. The magnitude of these points. So the absolute value is equal to the square root of a squared plus b squared. 3 squared is 9. We have 2 squared, which is probably 36 or more, like 36.4, I think. 0.2 squared. Oh, no. So we have 38.44. I guess the resultant force would be like 6.9 or 6.89.
Sorry, my dad thought it was very important to know how to spell liaison.
What was that? Sorry.
Sorry, my dad thought it was important to know how to spell liaison. So,
Okay,
sorry about that.
that's okay. Just use the volume real fast. Sorry, my brother's watching Netflix in the other room, so.
That's fun. Okay, so what were you saying about how to solve this?
I was looking in the textbook to find, let's see, where was it? It's on page 612, and it says component form of a vector. I could be off there. It's where you add the horizontal and vertical components. The absolute value of v is equal to the square root of a squared plus b squared. And so I squared 3 and I squared 6.2. And I did the square root of that. My answer was either 6.9 or 6.89, depending on how many decimals we wanted. So that could be the new magnitude. In the direction. Or if we didn't even take the square root, it'd be basically. Hold on, let me make sure I got my math right. It'd be the square root of 47.44. That way we'd have to take it into account if we weren't going to square all the way. Let's see, direction angle.
So, the resultant speed would be the square root of 47.44, which comes out to be 6.89. 6.9.
Yeah.
Well, okay. Yeah, I'll do that.
Okay. So to find the direction angle, use trigonometric ratios to get the sine of theta by is equal to b divided by the square root or the magnitude. So the inverse sine of, let's see. So the inverse sine of 6.2. Let me make sure I'm getting this right. Yeah. There we go. I have 6.2 divided by 6.9 is equal to. Let's see, I get 64.1 degrees.
Yeah, that's what I got too.
Okay. Okay, number 2. This will be fun. I'm not as good at the polar stuff yet, so.
Yeah.
Let's see. Write an equivalent rectangular equation for the polar equation of r is equal to 10 over 3 sine of theta minus 7 cosine of theta.
All right. Well, you know, in division, you have to bring over the 3 sine
Mm-hmm.
and distribute the R. And then you can substitute R sine of theta for Y. Yeah. So 3y minus 7x equals 10. And I guess if you solve for
We'd be solving for x, correct?
I'm guessing so, yeah.
So let's see. So minus 3y over there, and then divide by 7, so x would be equal to, let's see if my math is correct. Is 10 part of this, or are we not worried about 10? I just realized I went through a loop there.
Yeah, 10 kind of just stays on the right side the whole time. So
y, and then minus, because
yeah.
3y is negative when it first goes over, then the negative 7 cancels that out, makes it positive, so.
Mm-hmm.
So would you say that's the answer?
Yeah, that's what I would say.
Okay. All right. Write an equivalent polar equation for the rectangular equation. Squared plus y squared is equal to 9 y over x squared.
Okay. I know off the bat we can probably substitute x squared plus y squared for r.
Mm-hmm. Y over x, what does that equal again?
Y over x is... well, then I wonder if it wants, like... I don't know. It wants, like, if it wants r cosine of theta over r sine of theta. Or sine of theta over r cosine.
Let me look it up real fast. I had it here somewhere. See, r is equal to the square root of x squared and y squared. And tan of theta is equal to y over x. Oh, here we go. So x squared plus y squared is equal to r squared. That's the equivalent. So we have r squared.
Okay. Yeah, it's r squared.
Okay.
And we
R
can
squared
r
is equal
squared.
to 9. Oh, sorry. R squared is equal to 9 tan of theta squared. I wonder if there's a way to simplify it further than that.
I think maybe even before we turn y over x to a tangent, we can take the square root of everything. So it takes off. So it'll be r equals 3 y over x. And then you can turn it to r equals 3 tan of theta.
Oh, okay. Yeah, I think you're right. Actually, I like that better.
Yeah.
Okay. So 3 tan of theta. Okay, graph the polar coordinate 4 and 4 pi over 3. An ordered pair in polar coordinates names a single point. However, the coordinates is not named two of the polar coordinates that are located in the same place as 4 and 4 pi thirds.
Okay. So, draw a little marking. I need to review my unit circle more. Okay. Down in this direction.
Let's see.
So two other polar coordinates that locate on the same. The first one that I think is pretty off the bat easy is like the negative. So like 4 negative 2 pi over.
Did you say use the unit circle?
Yeah, well, I was saying I need to review my unit circle better, but yeah,
Okay.
4 pi
'Cause
over 3 on the unit circle.
okay, because 4 pi thirds is equal to just pi thirds. You know, that's just going around the circle once and going into pi thirds.
And
And
4,
let me see here.
4 pi over 3 is 240 degrees. So
Oh, wait, you're right. Yep.
yeah, so another polar coordinate that could go there would be negative 2 pi over 3.
Mm-hmm.
Trying to think of other.
Well, there's 4 also, and that's 4 pi over 3. So let me think. Hmm.
You could do the whole. You could do like a kind of like a 360. Like you go past it and you go around again. So like, hold on. 4, 5. So,
Let's see.
10. So like 10 pi over 3.
Yeah, probably. I'm just
I
trying
have
to get
no
this wrapped
other
around.
idea what else to write there.
Here, let me see. Maybe the textbook can help us out. Coordinate. Page 535. Let's see if that helps. Polar coordinate. In the rectangular coordinate system, points are named according to their position with respect to the x-axis and y-axis. Okay.
the bottom of that second paragraph. Any ordered pair in polar coordinates names a single point, but the coordinates of a point in polar coordinates are not unique. For example, negative 2 pi over 4, 2 5 pi over 4, and 2 negative 3 pi over 4 are all at the same point.
Okay, so it's opposite on the other side then.
Okay, yeah. So it'd be a negative 4.
So yeah, negative 4, and then just simply pi over 3.
Yeah. Okay,
And then you.
there we go.
All right. Splendid. Okay.
Okay.
Yeah, that's it.
So
Right,
we
is there
got that done pretty quick.
I'm sorry you had issues with technicalities earlier. That's rough.
Yeah, it's fine. We made it work.